Okay, Chapter 17, How to Use Object Data Sources with ADO.NET. So this chapter talks about object data sources as opposed to what we've been using up until now, which was SQL data sources. And the idea behind using an object data source versus a SQL data source is that it helps you develop with this idea of a three-layer or N-layer, N-tier, sometimes you might hear it called database architecture or actually application architecture. And we'll talk more about that in a bit, but it helps with a lot of different things, scalability, making your application easier to handle more concurrent users at once. Well, that's redundant, but more users. What else are we going to talk about? Creating a data access class, and that's part of this. Is by using this object data source, it enables us to call methods that live in this data access layer, also known as a data access layer. It's that additional tier that we're going to be architecting. And then we're just going to look at, actually using this object data source with these business objects that live in this data access class or data access layer. So, what knowledge we're going over? Obviously, how three or N tier. They keep saying three layer, but N layer because it can have more than just the main three layers. N layer applications work, benefits of using object data sources, some of the underlying ADO.NET classes that are involved. So this is where we start to look more into the code behind ADO.NET. So we look at, when we're talking about SQL Server, we'll look at the SQL connection class, the SQL command class, the SQL data reader classes, and how to write code to call them. We'll talk about this idea in .NET of reflection and how the object data source uses the reflection. Which is basically, it goes out and looks at the commands that we're using and figures out what parameters need to be filled in for those commands. We'll describe the way business objects are used with object data sources and talk about paging and sorting and basically how when you use object data sources, this becomes much more of your own responsibility. It's not really automatically done for you. So what is the three-layer architecture in ASP.NET? It's this idea of having a presentation layer, which is the HTML pages that get sent to the user, a middle layer, so this is your data access class, all the classes, all the logic, sometimes people call this the business logic layer, but anything that's required to go get data from SQL Server and then turn around and pass it on to the end user through the HTML layer. And then finally, the third one is the database layer, and that's actually, in our case, SQL Server, but it could be Oracle or MySQL or whatever. So up until now, we've been putting, SQL data source, and SQL data source goes directly against SQL database and kind of been bypassing. We've been doing, almost what you would call client-server computing. In fact, when I teach this class as part of the Stevenson Master's program, the title is client-server computing. We generally actually don't even go over this chapter in that class because this is definitely a more advanced, one of the more advanced chapters in the book. That said, what this idea that this chapter talks about is actually, what people would call this enterprise level applications, where you're talking, 10,000 concurrent users. And not just scalability. I shouldn't say that because the other reason for implementing the middle layer is there's many other reasons. Probably a couple off the top of my head is for testability. So this idea of separating the data access classes from the presentation layer, from the database layer, allows us to test those classes to make sure everything is valid and working correctly. And not only testability, but also I can get other people to work on them by separating them out. Then I can have one programmer working on this, one programmer, or one or many working here, one or many working here, one or many working here, and that not only scales my application at runtime, but also at design time. So as I'm building my application, I have more team members working on it versus if it was all in one class. So a lot of benefits for developing a middle layer. So when we start to develop the middle layer, the biggest thing that comes into play is we're doing more coding. We're doing less. Up until now, we've been doing a lot of declarative programming, meaning we're doing a lot of drag and drop. We're putting server controls on the page. We're configuring those server controls, but we haven't been doing a whole lot of going into the code behind and writing code for the classes. This chapter does more of that because when you develop a middle layer, you're having to create your SQL connections using code. And this is one example of one of the objects we'll create, the SQL connection, which takes a connection string. and you have the open and close method. These have been called for us automatically in some of our previous examples. Other classes that we'll have to deal with: the SQL command class, which takes some SQL statement and a connection object to create a SQL command. It's got parameters, any SQL parameters that we have to pass to it. What are some methods of a SQL command object? There's an execute reader method, that is, go run some select statement and bring back some data. And then there's a execute non-query method, which is for the other three CRUD statements. So the insert, update, and delete. So if I need to do an insert, an update, or delete, I would use execute non-query. But if I do a select statement, I use execute reader. And then down here, this is this add with value. This is, as I'm adding SQL parameters to any of these commands, I can add the name of the parameter and the value using this method. So a data reader object is created by the execute reader method. So if I have a SQL command and I call execute reader, it actually instantiates or creates a SQL data reader for me. So I don't have to use the new keyword in C# to actually. You guys might remember from way back in the beginning, I think I did a quick intro to C#, and I mentioned the new keyword allocates memory, and then the constructor of a class would actually instantiate or initialize the newly allocated memory. Well, the execute reader method has all that encapsulated in the method, so it goes and instantiates a data reader object and then initializes it as well. So there's no new keyword required here when you call the execute reader method. There's an indexer of the SQL data reader class, so if I want to get to first name, last name, etc., I would use these brackets and then the name of the column to get to those particular rows of the execute reader object. I can call the read method, which reads the next available row of data. If this comes back false, that means that we're at the end of our result set, and so we time to exit the loop. And then the close method says, okay, we're done reading data. Please clean up any unmanaged objects. Unmanaged objects being any objects that .NET doesn't automatically garbage collect, doesn't reclaim the memory for. So here we have a drop-down list bound to a object data source control versus in previous we would have done a SQL data source. Very much in the setup, similar to what we've done before. We would, click on the drop-down list box, select the new data source, select object data source instead of SQL data source, and then once we click it, we would do the little configuration with it like we've seen in the past, and this is what the result that we would get. So the drop-down list box is there's the data source ID, the name of the data source, and down here we still have the display field and the value field. Down here, there's our object data source. The difference now is we're not pointing at a SQL Server database and a connection string. We're telling it what class, the type name means which class, and this is my data access class, am I looking at to get data from. So in this case, the product DB class. So there's going to be some product db.cs file in my project or some DLL that I'm referencing to get this class data. And then in that class, what method, what function is my select statement? In this example, it's the get all categories method. So this is what the product DB class would look like, and specifically the get all categories method in that class. You guys might recall that a class can have obviously multiple methods. So here's the get all categories method, and what it does is it goes and creates a SQL connection using the SQL connection class that we just talked about. Gets a connection string from wherever it happens to be stored, probably web.config, sets up a string, which is a select statement, and uses that string in conjunction with the connection object to create a SQL command. Once that SQL command is created, we can open the connection, execute the reader, and then return that reader. We probably should have had a closed connection, or not a closed connection, but a close the reader when we're done. Or actually, in this example, we're just getting it, so presumably the looping through of the data reader happens elsewhere, and then once we're finished looping through, we would close it and then close the connection. So here we're doing the first part where we're opening and getting the data reader somewhere else. Someone else is going to loop through it and then close it when they're done. Some other things to point out here is this public static INumerable which is in front of our method. And what this is saying is it's a static method, and your book talks about whether your methods can be static or they don't have to be static. If they're static, that means they get created when the program first runs. So it doesn't have to have it doesn't have to be a non-static method would be instantiated, or the memory allocated every time it's called. This way, it's instantiated the first time. The memory is kept the whole time, but it's not constantly tearing down and recreating every time. So the author says that this is better for performance from a performance standpoint, and I tend to agree. IEnumerable is an interface type, so it says that this get all categories will support certain methods that the IEnumerable interface requires, and this type of data access layer, the object data source, requires certain methods to be implemented, and that's what this IEnumerable is making sure is happening. So when we do our get all categories, it knows that the IEnumerable says, hey, it's going to return some object that supports looping through. So the data reader isn't an IEnumerable object and will support looping through. So we're all copacetic here because we've agreed that we're going to be IEnumerable. We're returning a data type that supports IEnumerable. Finally, this thing up at the top, we'll talk more about this later, but this is called an attribute in .NET. And what this means is and the word they use is decorates the method. So we're decorating our method here with the data object method attribute. And then that attribute we can pass parameters. In this example, we're passing the select data object method type. So data object method is what they call an IEnumerable, and basically it's just a list of values. So if I were in my code and I hit dot, I would see select, insert, update, delete. So I've got 4 different choices of the data object method type. In this example, I'm saying this is a select data object method type, and this whole method is a data object method. By putting this attribute on right in front of that method, I'm decorating it and saying it's a data object method. By doing this, this lets my program or my Visual Studio know that this is a selectable data object method, and it will show up whenever I say show me all data object methods in the wizard. So let me show you some of this before I go too much farther. Jump out to my Visual Studio. And let's open up, and for this one, previously I've been opening up a lot of the exercises that you guys do in the back of the book. But in this example, I'm actually going to go out to my Murachs directory and open up the book application. It's a little more fleshed out than the exercise. So I'll go ahead and open that up. And what I want to show you here is in this exercise, or excuse me, in this book application, I've got my app data like we're used to, but now I have this app code directory, another special directory in ASP.NET, where I've placed my category DB. This is my data access layer for this application. And you can see it's got these methods. In this example, it's got get categories, which is a data object method. What kind? It's a select. This is where I mentioned that if I use my IntelliSense, I get the other options that are available. If I scroll down here, I've got another one for insert. I've got another one for I actually have 2 for insert. This isn't in your book starter code. I was messing around earlier, and so I added an insert 2, and I'll show you why I did that in a minute. And then you've got delete, and notice it's decorated with the delete data object method type. Now we have one up here that's not decorated. Where's that guy at? The connection string. So there's no attribute here. And here's why you would decorate and you would not decorate. When I go to my data page, or my default ASPX page, I'm in design view. So here's what we're used to seeing. I've got my data grid, and I've chosen a data source. When I created this data source, when I configure it, you select a business object. So this is looking for classes in my app code directory that are been decorated correctly. So if I uncheck this, it shows me everything. So there's category. Category is another class that doesn't have those attribute decorations. But if I say show only data objects, which is really the only ones I want in this particular wizard, it's going to only show me the ones that have been decorated correctly. So that's why that's important. And then as I step through this wizard where I'm defining methods that are associated with each of those CRUD statements, you'll see it's also only going to show me those methods. So I'm not seeing get connection here because it's only showing me select methods that have been decorated with that select attribute. Same for update. It's only showing me update, delete. There's only one delete statement. It's been decorated with delete. Now, the insert, I added a second one, so you actually see two because they've both been decorated with the insert. Let me show you where that is. So back to my code for a second. So insert. We already had the insert category that was decorated with the insert data object method type. I went and I created a second one just so you could see that you can have more than one. So this is insert category 2. But again, since it's decorated, it shows up. If I remove this decoration and then rebuild and then go back to my wizard, now that second insert will be gone. Made a liar out of me. Did I not build? I probably went too fast. Let's do that again. Rebuild. Let's make sure I remove the decoration. I did. So it didn't save my default ASPX page yet, so let's save that. Now let's try that again. Let me set that to none. I think probably because I already had it in there. Let's see if that's the case. There we go. So I already had it in there. Now that I've removed it and rebuilt it and all that, it's not showing that insert the second method because it's not decorated. So, but if I wanted it to show up, what would I do? I'd go into my data access layer class. Let's say, oh, there's that new method I want to be able to make available. I would decorate it with that attribute, data object method. And I would say, oh, by the way, this is, what kind of method is it? It's a data object method type of insert. Rebuild this guy. Go to my default page, configure it. And what I'm doing here, so I'm simply saying, when this fires up and goes to get data, this is a select method I want to call. When someone does an update, this is the update method I want to call. When I do an insert, this is the insert statement I want to call. So now when I run this guy, let me actually put a breakpoint in my insert statement. So I'm going to put a breakpoint right there because we're saying call insert category 2. Let's run this guy. When I use the list view control down here and I put in, PX1, priority, X1, whatever, blah, 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 and I click insert, it's going to that insert to category and it's executing. So as we step through the code here, we notice that we're hitting the insert category 2 method. So we're stepping through here and we're executing this particular insert versus the one up top. If I wanted to switch and use the other insert category, notice the difference between mine versus the original that came with the program is they used the category object as a parameter, and here I'm using each specific category ID, short name, long name, each parameter broken out. So but the actual insert down here is the same in either one. So to switch and call a different insert method, I would simply change in my object data source which the insert that I want to call. So let's do that. Let's go out to my object data source, and we're actually still running. Let's finish running that. Where did we do it? That statement there. This guy. So it inserted whatever I did there. So that's fine. Close that guy. Now let's configure this to use the other insert statement. So we'll come in here and say, hey, insert category 2 was fine, but now let's switch to insert category. So one thing that's going to happen, these parameters that are being used, this is that reflection that I mentioned earlier. The object data source will go out and figure out that it needs to send the category ID, the short name and the long name. And the names are important, and I have to match the names. If I go to my category object, this is my category object, and there's these public properties. The names are important, so this category ID has to match what I just used, and the short name has to match what I just used, and the long name has to match what I just used. Because of this reflection that the object data source uses, it looks for these names and matches them up. If I change to, so if I say, hey, I don't want to use this method anymore, I actually want to use this other method. Maybe it's got some, better, whatever, some other program worked on it, and it's got a more proficient method of doing the insert. But it's using the category object. So now that I'm going to switch to using a different set of parameters, when I do this configure here, what's going to change, if I go to my source for a second, it's going to change from using this insert method will change to insert category, without the 2, but it's going to also say that the data types being sent is now the category data object and not just the parameters. As see down here, we have that we're passing the 3 parameters. So watch what happens. I'll go to my source, and I'll configure my data source. I'll say I want to use the other insert statement, which now expects a category object and not the individual strings. And now if I look at my source, it added what? The type name. It's saying, hey, now we're dealing with this category, this is what I was looking for, the data object type name. It's saying this is the parameter that we have to pass to in our example, the insert method. So here we're calling a different insert method, and we're using the category data object to pass as a parameter to it. So when I run this, let's put a breakpoint on my other insert statement. And run this guy. And now when I do an insert, it's called the other insert statement. And indeed it does. Now I'm stopped here at the other insert, and notice this time it passed a category object instead of where previously I had passed each string all by itself. So, as you design your data access layers, this is the kind of thing where you start saying, okay, I'll design this method, so I've broken out my data access into a different tier, and now I can start working and optimizing and doing, whatever I can do, because it's a layer of abstraction that enables me to do, optimization and scaling and things like that. All right, let that finish running so I can prove that it went in there. There it is up at the top. All right. So other attributes of the object data source, the type name we talked about, the different methods, the data object type name. There's this thing called conflict detection that will let you do optimistic concurrency. So you can actually, when you turn that on, you'll pass it 2 category objects, the original and the new one, and that way it can check to see if something changed. We went through this already, the little wizard for configuring the data access, and I mentioned the different defining the data methods. This is the product list application from the book that uses an object data source instead of a SQL data source. They mentioned that the product DB class has a get all categories method that brings all the categories back. There's actually 2 methods in this application. There's another get products by category ID that takes a category ID as a parameter. So that's for pulling just products for a given category. And this is what that code looks like, where you would have an object data source. So the drop-down list is tied to an object data source, and then the object data source, you choose which method it's going to use to pull back the data, and then what the data access class name is. In this case, it's product DB. So, and then in this example, they've got another object data source for the that's tying to the drop-down list box of category that's pulling down just products for that category. So I won't go through all this code. Again, I think we went through a lot of these slides already. We talked about all. Some other return types. So the example I gave earlier had IEnumerable, but you can have other return types. Again, as long as these all return something that the control can loop through basically. So IEnumerable is one of them, but there's also data type, data set, object. In the book, they mention that data set's a nice one because if you remember, data set it's sort of a whole in-memory representation of a database. So I can actually have multiple tables and they can be joined and all that other stuff. So a data set is actually easily cacheable. So that's a nice benefit of returning a data set. Then we can just cache it at the middle tier, and it saves us trips back to the database tier. And any trips between different tiers of your application are always expensive. So caching becomes a big deal. Whenever you can cache something, it saves you that trip and helps your application perform better. So more examples of select methods. This example, we've got the get categories method that's returning a list of categories. Now, I don't know that we've seen this. This is some more C# stuff, but this is what they call a generic type in C#. So the list is a generic type, and what it does is if you pass it a class or some other data type that you want, it's kind of like an array, if you will, if you're familiar with arrays. But we're saying, give me a list of categories. This could be a list of strings, it could be a list of ints, but in this case, it's a list of categories. So it's a collection is the proper term in .NET, a collection of categories that will get returned. So when we create this category list, it's a collection of categories. Then we can return that. It's a proper data type to be returned to a data object method. An example of a typical update method, this is with optimistic concurrency turned on. How do I know? Because it's passing two parameters. One is the original category, the second one is the updated category, and we can use that to say, let's make sure the short name, we add our where clause so that we make sure that we get the original value. If this comes back as empty, then we know that there's been a change and we need to do some conflict resolution with the user. This goes into how the parameters are generated. I mentioned some of this already, so I won't go into much more detail here. I mentioned that names have to be the same and things like that. Some other requirements when you're developing your data access layer, your class has to have a parameterless constructor, which typically C# will generate for you automatically anyway, so it's usually not an issue. Has to have public properties. The names have to match the name of the bound fields. I mentioned that earlier. And they have to have both get and set accessors. So let's see, we don't have an example of that here, but let me jump out to my code and show you what they're talking about there. So in my category name, I've got a public, this is my public property short name, and it has to both have a way to set it, there's my set accessor down here, and a way to return the internal name, which is usually, this is a convention that people use all the time where they do camel casing. So you see the capital S and the capital N for the public property, and then a lowercase s and a capital N for the internal private property that represents the data. So each of these guys has an internal private variable, but then out here you have a public property that uses a getter and a setter to provide access to the internal variable. This is all done for encapsulation. The idea is if I ever want to change, maybe I don't want to make this a single string. Maybe I want it to go look up from a database. Maybe I want it to be two strings or some other representation internally. I could change this, but I wouldn't change the public property. That represents a contract to anyone who's using my data access layer, and I don't want to break that. Otherwise, it would break compatibility with my code. So I can change the internal without breaking the external interface to the users. Got a little C# heavy there for a second, but that's what this chapter is all about. Breaking out the C# and getting more code heavy to make your application more scalable, maintainable, things like that. More attributes for marking data access classes. So we already talked about the data object and data object method and the different types that are available. This is simply, these next few slides are just examples of a data access class that's been marked up. So you can see this get categories is a select data object method. This is the example of their category maintenance application that uses, and this is what we just saw earlier, uses a data grid to pull back the data and a list view to insert new data, but both of these are tied to object data sources instead of SQL data sources. The different methods that we implement, and then the method types. and then this goes through some of the code. And I'm not going to. There's that conflict detection setting. If we want, and that means we're going to have to use those. It's going to send those both an original and the updated category parameters. And this is all in your book, so I'm not going to go through. I'm just looking for things that we've kind of shouted out most of this stuff already. Now, paging and sorting, again, because we're using object data sources, and I don't know if I iterated it enough earlier, but when you use a SQL data source, the paging and sorting is provided by the data source and not the control. So when you switch and now you are using an object data source, that particular control doesn't do paging and sorting automatically. So if you want paging and sorting, it's a little more than just clicking and saying enable paging. We actually have to specify the select count method and sort parameter name and so all these other objects. So here's an example where we're saying, hey, we've got an object data source and we want to allow paging to occur, so we set it equal to true. But then we have to go in further and specify, of course, the sort expressions. But down here is where it gets in the object data source, where we say, hey, there's a method that we want to use, and we specify the sort parameter name and the maximum rows parameter name. So in our data access layer, we actually have to say how we're going to implement that. So here's an example where we're actually trying to, on the first page load, we're saying, hey, has it been sorted? Let's go store that. This is the first page load, so let's store a variable in view state that says this is the initial sort. And then if we're not the initial sort, we'll go and pull that variable out of view state and reset it, if you will. And finally, the data access layer used by the object data source. This is the whole data access class, so the product DB. We've got the select methods. Now we have the sorting added to. So we've taken our data access layer and we've added sorting capability to it. So in here we say, hey, given a sort order string that's been passed, we will add to the select statement whether how we're going to sort. So in this example, we're looking for the variable name, or this is our column name, and this is actually a SQL command, descending. So we want to go in descending order. And up here, if we're sorting by product ID, then we sort by product ID. If we're sort product ID descending, then we use this code to change it. And in this example, we're using these, order by descending method, order by to switch up the sorting. So again, some advanced stuff. When you start using the object data source, you take more responsibility for some of the stuff that you got sort of automatically with the SQL data source. So exercise 17.1 has you implementing an object data source and hooking it up to they don't ask you to write the data access layer. That's already done for you in exercise 17.1, so you don't have to worry about that. You can just look at what they have. That is kind of an advanced topic, but they do have you hook up an object data source to an existing data access layer, so you can at least get that much done. If you want to see the more advanced data access layer, then instead of opening the exercise, or after you've done the exercise, take a look at the book application in exercise 17, which has the more fleshed out data access layer. Thank you, guys.